Hello everyone, welcome to Infinity Physics. In this lecture we will discuss about parallax method. Parallax method is generally used to measure the distance of a planet or a nearby star. So what do you mean by parallax? Parallax is nothing, it's a simple term that we are observing in our day-to-day life. If we try to observe anything from our one eye, we will observe at some different position, and then we will try to observe with the another eye, it will again we will observe that it is shifted. So that shift, it is apparent, the object is not actually shifting, right? So that shift is apparent. So that apparent shift is called parallax, and that angle, right, and that angle we call it a parallax angle. So that simple phenomena we can use it to calculate the distance of a planet. But if we try to observe the star which is very far away, we call it the infinite distance, then if we try to observe like this by closing our one eye, then we will not observe any shift, right, because it is very infinite and all the rays coming from that are parallel rays. So these parallel rays are coming from that distant star which is at very far distance. So these rays are falling at this particular point, it is falling at all the point. We will consider only 2 points, and then we will put our telescope at these two positions A and B, and we will try to observe this planet from these two positions at the same time, right. So if I try to observe this planet from this position B, then I will observe it here. So this will make an angle theta 2. Similarly, if I observe this planet from position A, then it will make an angle theta 1 with this line, it is the imaginary line. Then if we use the rules of trigonometry, then this is an alternate angle because these two lines are parallel. So this is an alternate angle, so this angle is also theta 1. Similarly, if we make here an alternate angle, then here we will get another angle theta 2. So these two angles are same and these two angles are also same. The net angle, that is the net shift, okay, how much it is shifted, angular shift, that is called the parallax angle. So here the net shift is theta 1 plus theta 2, which we called here theta. So we are getting a triangle like shape here, and this arc, okay, we will consider as a straight line. So we are getting a triangle like shape. So we know that if we want to calculate the theta of this triangle, right, so we have a equation theta is equals to arc by radius. Then we want radius, so we will make radius as a subject, then radius is equals to arc by theta. So radius is equals to arc by theta. Here r is equals to, what is our r? What is our r here? This r is this distance d. So here instead of r I am putting this d. Then we have here arc. What is our arc? Our arc is this distance AB. So I am putting here instead of arc I am putting here this distance B, and this distance it is on the earth, and that we can calculate easily. And then we have here theta, right. So this theta, this angle theta, which can also easily calculated, right. And then by putting all this value, right, the distance between these two positions on the earth, we can calculate this theta with the help of instrument, we can calculate, right. So by knowing these two value, we can find the distance of this planet. Now we will try to find the distance of the moon from the earth. So you can easily understand how these methods are useful in calculating the distance of a nearby planet or a star. The question given is, the moon is observed from two diametrically opposite points A and B on the earth. The angle subtended at the moon by two directions of observation is 1 degree 54 minute. It means when the moon is observed from these two opposite diametrically opposite points from the earth at the same time, the angle subtended by these 2 points is observed to be 1 degree 54 minute, that we call a parallax angle. So, other data given, B is equals to, that is the diameter is 1.276 into 10 raised to 7 meter. What we have to find? The distance of the moon. It means we have to find this distance D. Here theta is given, the parallax angle is given 1 degree 54 minute. We know that 1 degree is equals to 60 minutes. So, if I convert this 1 degree into minutes, then it is 60 minutes plus 54 minutes. So, we will get 114 minutes. Now, again I want to convert this 114 minutes into degree. So, how I can convert it? 1 degree is equals to 60 minutes. So, 114 minutes is equals to how many degrees? So, by cross multiplying, what we will get? 114 by 60 degree. So, here 114 minute by 60 degree. So, we will get here degree. Now, I want to convert this degree into the standard unit, SI unit. So, I have to multiply it with pi by 180. So, I will get the final answer theta in radians. So, I have theta is equals to, by solving this, we will get 3.32 into 10 raised to minus 2 radians, that is our theta, and this B, this diameter is given 1.276 into 10 raised to 7 meter. Now, we know that theta is equals to arc by radius. This theta is equals to this arc by radius. So, I want this distance, so I make this distance subject. So, r is equals to arc, this arc by this theta. So, I can modify this, also we have derived few minutes ago. So, d is equals to, here our r, this r distance, this r radius is our d, and this arc is given here b, and this theta, okay, it is given here 3.32 into 10 raised to minus 2. By putting all this value, we will get the distance of the moon from the earth is 3.84 into 10 raised to 8 meter, or in simple words we can say it is 3,84,000 kilometer. I hope you have enjoyed my lecture. Please share your feedback in the comments, and also help me to reach maximum students. Have a nice day.